Good morning, everyone. So yesterday we were solving Kramer's rule problems. So in that we started with first question where we will be given two equations, and those equations are supposed to be in the format of ax plus by is equal to c. If they are in this format, only then we'll be able to solve using Kramer's rule. Correct? So then using the two equations, we formed determinants, wherein we'll be forming three determinants. First one will be delta, second one will be delta x, and the last one will be delta y. So first one, that is delta, is nothing but the coefficient of variables x as well as y was considered. So if you see here, delta, the determinant value 3 and 5, 6 and 5, that is what is considered. Now, once you have a 2 into 2 matrix, you have to find the value of the determinant of 2 into 2 matrix. So that is just by cross multiplication, 3 into 5 and 6 into 5. You have to subtract both of them, and the delta value what we found was minus 15. Now after this, we have to first find out, or first we have to analyze if the delta value is equal to 0 or not. Now if you see, delta is minus 15. So the delta value can be plus or minus value, but it should not be 0. So here, since it is a minus value, there is no problem. So we can go to the next step. In the next step, we will be considering this constants, that is 8 and 11 in the place of 3 and 6. So in the place of 3 and 6, we have replaced the constants 8 and 11. And we get a new determinant, and this is delta x. Now, once we find the value of the determinant, we again get minus 15 as the value of delta x. After this, in the next step, to find the value of delta y, the same 8 and 11 constant will be replaced for the second column. So in the second column, instead of 5 and 5, we have replaced it with 8 and 11. And we have a new determinant, that is delta y. Now solve this determinant, we again got minus 15 as delta y. We had stopped until here. Now the final step that is remaining for us to solve here is to find the value of x and y. Now since we know the value of delta, delta x and delta y, it is easy for us to find out the value of x and y. So moving further, let us find the value of x and y. So x is equal to, the formula to find x is delta x divided by delta. And similarly, to find the value of y is delta y divided by delta. Okay, so what is delta x? Delta x is minus 15 divided by delta is also minus 15. So minus 15 by minus 15, the value of x will be 1. And if you see delta y, again the value of delta y is minus 15 and the value of delta is minus 15. Again the value of y will be equal to 1. Okay, so therefore x is equal to 1 and y is equal to 1. This is our final answer of Kramer's rule. Everybody understood this part, this problem? Any doubts in this problem? Can we go to the next question? Okay. Now we have the next two equations given to us, and they've asked us to solve this using Kramer's rule. So let us do the same activity, but in this problem you need not write all the explanation. Okay, since that was the first problem, I made you write all the explanation. Here you can directly solve the problem. Fine. So let us start. Solution. So we have two equations given. Let us first form the delta. So delta is equal to, be careful with the sign, 5 minus 3 minus 7 and 11. So if you observe here, you have minus 3y and I took minus 3, the full coefficient along with the sign I have considered. And if you see minus 7, consider complete the number along with the sign. If it is plus, then no problem. You can directly put the number. Since it is minus, you have to consider the minus sign. So this is the value of delta. Now let us solve this delta. Now how do we solve? By mere cross multiplication. So 5 into 11 minus 3 into minus 7. Let me put a box bracket here so that it's even more clear. Now solve this. 5 into 11 is 55 minus 3 into minus 7 will give us minus into minus plus. So it will give us 21. It will be 21. So the value of delta is 55 minus 21 is 34. Good. Very good. 34 is the answer. So we found out the value of delta. If you are getting confused, you can just write down delta is equal to 34. Now, let us find out delta x. Now, what should be my determinant for delta x? What should be my determinant? Write the matrix. No, Spurti, it's ulta. For determinant, for delta x, change the value of x. So if you see in the problem, 5x minus 7x, correct? No, Aina's no, wrong. Yeah, Bhavya, answer is correct. Yeah, correct, Gauri. No, Spurti. No, wrong. Listen here. Somewhere you're getting confused. Now, 5x minus 7x. So 5 and minus 7 are the coefficients of x. Now, when you're forming delta x determinant, change the x here. Change the x. So change the x to the constant. What are the constants? 24 and 14 are the constants. And what is remaining? Minus 3 minus 11. Let it be like that only. Let it be like that it is. Fine. Now understood? Do not get confused. Please do not get confused. You are only changing the first column. This is column. Top to bottom is column. Right to left is, or left to right is row. So you are changing the first column, that is top to bottom. So that will change to constant. Now solve this and say me the value of delta x. 24 into 11 cross multiplication minus 3 into 14. So 24 into 11 is 264 minus of 14 into 3 is 40. How much is 14 into 3? 42. Minus 42. No. Yeah, minus 42. Correct. So 264 plus 42. How much do you get? 306. So therefore, delta x is equal to 306. Correct. Good, good. Now, delta y. What should be the determinant for delta y? Who will answer first? Let's see. What should be the determinant for delta y? 5 minus 7, 24 and 14. Good, Pujana. Any more answers? Okay, okay, Spurti, good. Correct, correct. Now you are able to understand, right? So, x will remain as it is. The second column, that is y values, I am changing it to the constant. Now solve this. 5 into 14 minus 24 into minus 7. So 5 into 14 is 70 minus of minus 168, which is nothing but 70 plus 168. Therefore, delta y is equal to 238. Very good. So everybody got 238. So we know what is the value of delta x, delta y and delta also. Now let us find out the value of x and y. Therefore, x is equal to delta x divided by delta, y is equal to delta y divided by delta. So what is delta x? Delta x is 306 and delta is 34. So 306 by 34 and delta y is 238 by 34. Now what is the answer you get? X is equal to 9, y is equal to 7. Good. So if you divide 306 by 34, you get 9. 238 by 34 is 7. So therefore, x is equal to 9 and y is equal to 7. Everybody understood? Any doubts in the Cramer's rule? Good. So those were the two equation Cramer's rule. Now let us learn 3 equations. Now when you have 3 equations, you will have 3 variables also, x, y and z. Okay. Now to practice, I will give you some more questions of 2 equations. You can practice, and if you have any doubt, if you're getting confused, get back to me and learn it. It's a compulsory question, I've already told you. Okay. Now let's go to the 3 equation Cramer's rule. Now 3 equation Cramer's rule, you have 3 equations that are given. So let us form the determinant. Now here you will have 3 into 3 determinant. So here there are 3 variables. Which are the 3 variables? X, y and z. So to solve this, we can take 3 by 3 determinant or 3 into 3 determinant. So let us calculate the delta. Now calculating delta or forming the delta, now for example, I'll write all the x values here, I'll write all the y values here and z values here. Just for reference, you need not write this. Okay. Now let us write down. So if you see the first equation, 2x 1y minus 1z. Okay. 2x 1y minus 1z. Be careful with the signs once again. That was first row. Now second row, 1x 3y 2z. Yeah, correct, Anas. Now for the final equation, correct, Pawan, good. Final equation, 3x minus 1y, but there is no z. Yes, very good. Correct. So since there is no value, we will take it as 0. Very good. Okay. So this is our determinant. Now we have learnt how to solve the determinant of 3 into 3 determinant. How do we solve 3 into 3 determinant? Yeah, correct. Everybody are giving the correct answer. Now say me, how do we solve the 3 into 3 determinant? Let's see who all can answer. Plus, minus, plus. Okay, that is sign position. What is the method? That is correct. Sign position is correct. Find the minor. Very good. You have to find the minor method. Yes, good. So let us start solving using the minor. So here we will be using the first row. Since it is easy for us, we'll be using the first row. Now first row I am taking first element. Since I am using the first row, as you all already told, it is correct. Plus, minus, plus will be the sign position. So first I am taking first row, which means which will be my first minor. Correct. Gauri, the answer is right. So 3, 2, minus 1, 0 will be my first determinant. Correct, Anas. Then minus 1. What is the second determinant? I want others also to answer. Good, Bharat. That's the right answer for the first one. Now say me for the second one. 1, 2, 3, 0. Okay. 1, 2, 3, 0. And finally, minus 1 again. Why minus 1 again? So if you see here, it is minus 1. So what you can do, if you're getting confused, you can write it as plus of minus 1. Plus of minus 1. And I will write the determinant below. Okay, don't get confused. I'll write the determinant below. Now say me the determinant for the last one. For this. For minus 1, 1, 3, 3, minus 1. Very good. 1, 3, 3, minus 1. Now solve this and say me the answer. Solve this and say me the answer for delta. Let us see who can answer. 3 into 0 minus 2 into minus 1. Minus 1. 1 into 0 minus 3 into 2. Minus 1. 1 into minus 1 into minus 1 minus 3 into 3. 20. Very good. Everybody has got the answer? 20. Great. Very nice. So 2 into 3 into 0 is 0. Minus 2 into minus 1 is plus 2. Minus 1. 1 into 0 is 0. Minus 3 2s are 6. then minus 1, here minus 1, minus 9. So 2 into 2, minus 1 into minus 6, minus 1 into minus 10. So 2 2s are 4, 6 1s are 6, 1 into 10 is 10. So therefore, delta is equal to 20. Correct. Delta is equal to 20. Now let us go on and find delta x. Now to find delta x, I have to first determine the determinant. Now going back to the question. Now if you see the question, the constants are 6, 3 and 5. So I have to replace the first column. The first column has to be replaced with the constant. So in the place of 2, 1, 3, I will be writing 6, 3 and 5. Similarly, for delta y, I will replace 6, 3, 5 in the second column. For delta z, I will replace 6, 3, 5 in the last column. Okay. So first let us find out delta x. So the values will be 6, 3, 5 and then we have 1, 3, minus 1 and minus 1, 2, 0. Correct. Very good. Everybody is right. Now start solving. 6 with the determinant value. Find the determinant here. 3, 2, minus 1, 0. Minus 1, 3, 2, 5, 0. Again, plus of minus 1, 3, 3, 5, minus 1. X is equal to 40. Correct, Pawan. Very good. Others solve. Yes, correct, Ashwini. Others solve and say me the answer. So 6 into 3 into 0 minus 2 into minus 1. Minus 1 into 3 into 0 minus 2 into 5. Minus 1 into 3 into minus 1. Okay, I'll write this below so that we don't get confused. Minus 1 into 3 into minus 1 minus 3 into 5. So is equal to 6 into 0 plus 2 minus 1 into 0 minus 10 minus 1 into minus 3 minus 15. So 6 into 2 minus 1 into minus 10 minus 1 into minus 18. X is equal to, delta x is equal to 40, not x is equal to. Delta x is 40. There is a difference between x is equal to 40 and delta x. Okay. So that is delta x is equal to 40. So 6 2s are 12 plus 10 plus 18. So therefore, delta x. Okay, wait a second. Therefore, delta x is equal to 40. Very good. Now go on and solve for delta y. Okay, x is equal to 2, correct. Go on and solve for delta y and delta z. Find both the answers and say me the final value. Now find out delta y. So for delta y, the second column should change. So the first column 2, 1, 3 will remain same. The second column will be replaced by 6, 3 and 5. And the third column will remain same, that is -1, 2 and 0. Now find out. 2 into 3250 minus 6, 1230 minus, sorry, plus of -1. The determinant is 1335. 2 into 3 into 0 minus 5 into 2 minus 6 into 1 into 0 minus 3 into 2 minus 1 into 1 into 5 minus 3 into 3. So 2 into 0 minus 10 minus 6 into 0 minus 6 minus 1 into 5 minus 9. Okay. So in the next step, 2 into minus 10 minus 6 into minus 6 minus 1 into minus 4. So 20. This will be minus 20 plus 36. 6 6 are 36 plus 4. So therefore, delta y is equal to how much? No, y is not 14. What is the answer you got? Y is minus 4. No, no, Anas. That's also wrong. Minus 20 plus 40. What will be the answer? It will be 20. So delta y is equal to 20. Now finally, yeah, y is equal to 1. It's not minus 4. Okay, again students, y is not equal to 20. Delta y is equal to 20. Okay. Don't have that y is equal to 20 in mind. You will forget to find the answer later. So this is delta y, which is done. Now, quickly find out delta z. Only the last column should be, yeah, y is equal to 1, correct. Now, the last column should be replaced with constants. So, delta z is equal to, so you first column will remain same, 2, 1, 3. Second column 1, 3, minus 1. And the final column 6, 3, 5. So 2 into 3, 3, minus 1, 5. Minus 1 into 1, 3, 3, 5. And then plus 6 into, I'm writing the determinant below, 1, 3, 3, minus 1. Delta z is minus 20. Correct. Correct, Bhujana. Delta z is minus 20. Gauri, delta y is 20. Correct. Now solve this. 2 into, since see, they can ask this for 14 marks or the section C question. So what you can do is you can elaborate each and every step and write, because steps also will contain marks. It's always good to elaborate each and every step instead of directly multiplying and adding them. Okay, so let us elaborate the steps here. So you will have 3 into 5 minus 3 into minus 1. Then again minus 1 into 5 minus 3 into 3. Then again plus 6 into 1 into minus 1. No, I'll take it like this. Minus 1 into 1 minus 3 into 3. So in the next step, 2 into 3 5s are 15 plus 3, because 3 into minus 1 is minus 3. Minus 1 into 5 minus 9 plus 6 into minus 1 minus 9. So 2 into 18 minus 1 into minus 4 plus 6 into minus 10. So 36 plus 4 minus 60. Therefore, delta Z is equal to minus 20. X is equal to 2, Y is equal to 1, Z is equal to minus 1. Very good. Correct answer. Everybody has given the correct answer. Okay. So finally, X is equal to delta X by delta, Y is equal to delta Y by delta, Z is equal to delta Z by delta. So delta X is 40 by 20, which is nothing but 2. Delta Y is 20 by 20, which is 1. And delta Z is minus 20 by 20, which is minus 1. So finally, therefore, X is equal to 2, Y is equal to 1, Z is equal to minus 1. Everybody understood? Anybody has doubt? Kramer's rule? Very good. Okay. Now, I will be sharing these problems where you can solve them. And if you have any doubt, you can get back to me. So let us go to the next concept. This is a concept which you have already learned, but there is a little, technical part that we have to add to the topic. Okay, can we go to the next topic? Minor of a square matrix. Okay, good. So listen. Now, we already know how to find the minor for a 3 into 3 matrix, right? Now, even for a 2 into 2 matrix, you can find the minor. So let us see how do we find the minor for the square matrix. Now, square matrix is something where the number of rows are equal to the number of columns. So if you see here, the minor of an element Aij. Now, Aij means A is the element, I is the row in which the element is there, and J is the column in which the element is present. So let us take an example. Let's say 3, 6, 8, 2, 7, 9, 5, 4, and 1. Now, if I have to say the placement of 3, where is 3 situated? I will say 3 is situated in first row and first column. Correct? Now, if I want to say what is the placement of 4, 4 is situated in third row, second column. Correct? So, rows will become I and columns will become J. So, when I am finding the values for a minor, the placement of each of the element is very, very important. So, minor of an element Aij is defined as the determinant of, this is some determinant of some square matrix formed by deleting. Now, to find the minor, just now we solved, right? To find the minor, we will be, sorry, this is submatrix. Okay, we will be deleting the corresponding ith row and jth column. What they are trying to say is, if we want to find the minor of, let us say, if we want to find the minor of 3, then we will not consider this first column and first row, right? So we are deleting that corresponding row and the corresponding column. And what will be the minor value for this? 7941 will be the minor for the first element. What is the first element? That is M. M is the minor. What is the element? First row and first column. Okay. Did you understand this? We are just finding the minors like how we did before. But here the denotion is given in a different way. That's all. Now let us try and find one more minor for you to understand it better. Now let us find the minor for the next element, which is 6. So 6 is the second element. Now where is 6 situated? It is situated in first row, second column. So I am finding the minor for first row and second column. Now, how do I find the minor? I will take out this column and the first row, and what is remaining? Okay, I can't even see the numbers. 5, 1, 9 and 2, I think. Yeah, first row, second column. Did you all understand how to find a minor? Yeah, good. Now we will keep finding the minor and we will keep solving that determinant to find the value of each and every minor. Okay, so this is an important concept for the further concepts that we'll be learning. Okay, there is one more important concept called inverse of a matrix. For that we require to understand minor and all that to solve. Now minor of A1 is determinant of subsquare matrix obtained by, what they are trying to say is, to find the minor of A1 I will delete this row and this column. So the minor is B2, C2, B3 and C3. See, B2, C2, B3 and C3. So I'm going to delete these first row and first column. Similarly, if I want to find the minor for B1, then I will delete the first row and second column and the values will be A2, yeah, A2, this is C2. Okay, sorry, it's not C3, it is C2. C2, okay, C2, A3, C3. And so on. I can find for every minor, right? For everything. But here we will be finding minors for all the 9 elements. Okay, every element. Previously we were only finding it for first row, sometimes only for second row. But here in minor we are going to do it for every element of the matrix. Understood? Any doubts till here? Okay. Now quickly, how to find a minor for a 2 into 2 matrix? Now to find the minor for a 2 into 2 matrix, same method. You will consider minor for A1.